All right, we are live with Anthony and Frank. This discussion is going to be unplugged for BoneChat members only. Go back and watch it. So Anthony's going to share his and Frank's stealth spine startup company, first time out. And I'm going to hand the mic over to Anthony and Frank. So welcome aboard.
No, thanks, Tiger. Yes, coming out of stealth mode. So we are MedTech Solutions, working on sacroiliac joint or SIJ pain solutions. All the kudos go to Dr. Frank Boehm, who's with us on the call, as these are his intellectual property that have gotten this far, and we are currently pre-revenue early stage with a partially developed SI joint fusion device, which we'll get to as part of this presentation. But I do want to introduce Dr. Frank Boehm, who I've worked with over the last 3 years. He's the neuro to my ortho, or the yin to my yang when we come to discussing opportunities in spine and orthopedics, and even outside of that.
Or doing cadaver labs, because you do it the ortho way and I do it the neuro way.
So
very nice to meet everybody. And I want to thank Tiger for hosting us today. I think that's just great. We appreciate it very much. Yeah. I know of many of your names. I've certainly been reading a lot of stuff that Elizabeth has written over the years, and it's a pleasure to meet her.
She's the BoneChat celebrity. Everybody knows her.
Although we met a long time ago at Emergo.
My crown. Wait, let me straighten.
But I'll open it up to Frank before we kind of go into the presentation on kind of how this evolved and what he saw, through his practice in the early stages of his career as a spine surgeon.
Well, thank you, Anthony. So I actually started my practice in 1991, and that was in the times when we were all just kind of getting used to pedicle screws, and the pedicle screw issues with Dr. Steffi hadn't been completely resolved. But I spent some time with Dr. Steffi, who I have to say to this day was one of the most incredible minds in terms of spine that I ever had the pleasure of knowing. And I spent some time with him and started to do instrumented fusion using pedicle screws. And we all knew and still know about the issue of failed back surgery syndrome and the complex nature of that entity. And I was trying to come to terms with how can I help these people that just aren't getting better. And some of them, at least, not all of them, but not enough of them, were telling me it was a kind of a different pain now. The pain had changed. And I had always learned, well, yeah, that pain does change and they have to learn to live with it. And being a diehard optimist, you can only be a neurosurgeon. You either have to be the penultimate pessimist or a diehard ultimate optimist. And so I was in the minority, being a diehard optimist. I thought maybe we could find a solution as to what their pain was coming from. And I started to notice that there was a subpopulation of people that I could really isolate the pain on palpation to their one or both of their sacroiliac joints. And maybe by 94, I was starting to inject these sacroiliac joints with steroids and getting some relief for these people. And, we do it a few times a year, and every patient was a little different, but some patients seemed to do better with periodic injections. I had a few that you just did a couple and they really turned around. So I was starting to get the sense that there was something to this. And I was even seeing patients that were coming in, sent to me to be evaluated for a fusion, and I wound up treating them for SI joint pain instead. And I remember in 1996, I was doing a presentation at the AANS on my findings and where I thought this might be going. And it wasn't extremely well received. As a matter of fact, one could say that if they had rotten fruit, they would have thrown it at me. It was they were so dissatisfied with this, the neurosurgeons, that the moderator, Charlie Branch, had to actually stop the presentation because there was just too much disruption from the audience. It was one of those little breakout groups, and there were about 35 or 40 people there, and I think they all came just to make fun of me. Afterwards, I was walking through the exhibit hall, and not one, not two, but three of them walked up to me and said, "Hey, if you wanted to be a chiropractor, why did you waste a neurosurgical residency space?" It was really not well received. Interestingly enough, I stayed at it, and 5 years later, 2001, in Sydney, I was at the International Congress of Neurosurgeons, and I found that my international colleagues were much more receptive to this, and some of them even wanted me to, few of them stayed in touch with me for a little while afterwards and were asking me about my techniques and how I was doing these injections. And, were sending me back emails saying, "Hey, I tried that. And there is something to this. I think there is a subpopulation of people that had this." And there were a few people that I even did a fusion on. Of course, that was sort of what you would refer as a more classic fusion. I was sort of doing the same thing they had described in 1921, exposing the joint, denuding it, and just sticking some bone in there. And then sort of got sidetracked with other projects and other things. And lo and behold, when I saw in 2009 the first report from the NIH that, hey, about 30% of people with low back pain actually have SI joint pain, I almost said to myself, that's interesting, because we used to say there was about a 60 to 70% success rate with spinal fusion. And I'm wondering if this is the other 30%. I was wondering if this was the other 30%. And a friend of mine and I started talking about what Anthony is going to show you. And in the process, I had come up with some other thoughts, but that's what led to Anthony and I met each other 3 years ago now, and on a different project, but we decided that this had enough legs to it that we wanted to really move forward. So I'm going to turn it over to my esteemed co-founder.
All right. Thanks, Frank. So, again, this kind of all centralizes around low back pain. And with the World Health Organization, there's up to 620 million people with low back pain today, and that's growing up to 850 million by 2050. It has surpassed anything cardiovascular in regards to disability. So it is the leading cause of disability worldwide. And here we have the opioid epidemic, and people want a quick fix to these pain sources. On the right, you see kind of a picture of the spine going down to the hips and the inflamed SI joints. But this is one of the fastest growing segments in life sciences. We know that there's a lack of industry innovation, and we'll get to some of these things. Currently, there's lots of fusions out there just in the U.S. alone. And to Frank's credit, there's a lot of IP that he has created around the sacroiliac joint infusion concepts, along with other stabilization pieces. And then there's kind of correlation from other surgical procedures that can lead to SI joint pain. But as Frank was saying, it's well studied in the literature, especially the NIH paper, that up to 30% of low back pain patients are misdiagnosed when the SI joint is the pain generator. And then on top of that, if they have a lumbar fusion or a lumbosacral fusion, then 40% of those patients will have adjacent segment disease below that fusion at the sacroiliac joint. So there are well over 60 plus lateral and posterior solutions on the market. I do want to highlight, if you do get low back pain, et cetera, you're typically getting, a discectomy, et cetera, that could lead to a fusion, which is here what you see on the top images with the x-rays, you know, extensive pedicle screws and interbody fusions to fuse that segment. But the middle diagram kind of shows the axial forces that come down from the upper extremities and transit down through the sacroiliac joints down to your lowers. And it also comes up as you ambulate, walk, run, etc., back up. So it does receive a lot of, it's a pretty big shock absorber, even though it doesn't have a lot of range of motion. And then to the lumbosacral fusions, you're getting, if you have the L4 to S1 segment fused, you're adding 168% more forces to the SI joint, whereas if you have L5 S1 fused, you're going to have about 52% added forces to the joint, which can add to the dysfunction of that joint.
And that explains, and may I just say that explains one conundrum, and that is there's been a number of papers that have shown that you have a higher chance of developing SI problems if you get an L4-5 fusion, actually, than if you get a L5-S1. And that's because of the change in the load. We all, as Anthony said, we all know this is not a joint that has a lot of motion to it. Most papers say 2 to 3 millimeters, 4 at the most. But I think that we're going to eventually find someday that the forces, it's a very heavily loaded joint, and the distribution of forces through that joint and through the pelvic ring in general are part of what's contributing to the pain. But anyway, Anthony, please go on.
Yeah, so it's been loaded with a lot of lateral approaches and solutions, but the posterior approach, and I'll have some slides to address these two things, is moving along and increasing, and there's more competitors coming in into the market to show that it is a relevant market to participate in. So spine surgeons will be our predominant targets, but on our medical advisory board, we do have a pain management physician who has 50 plus years of experience in pain management. And this is kind of where these patients kind of funnel through with these problems. But, interventional pain could have a place, but, you kind of have to tiptoe around it with it. Is this a spine procedure? Is it orthopedic? Is it neuro? Etc. So playing nice in the sandbox, so to speak. So this is kind of through Frank's story, he created an algorithm around it, and we're addressing one part of this algorithmic approach with the fusion, but there are other facets, including things on the injection side that we want to address down the road, but not our focus currently. And then looking at posterior stabilization as well to address SI joint dysfunction. So here, I just wanted to highlight the kind of joint, the SI joint kind of anatomy. This is kind of looking down your spine at a CT cut at the SI joint, and you can see the iliac crest and the sacrum here. But the principles of spinal fusion with lumbar fusion is to get in, take the disc out, put an interbody cage in, fill it with bone, and then lock it down with screws. So you have a fusion enabler and then something to stabilize to hold things together until that fusion occurs. So I do want to use the reference of mind the gap. If you've traveled overseas and you're on a people mover, you get to the end of the people mover and you hear the mind the gap. So remember the gap that is here, which is the sacroiliac joint. So 70% of the market is these lateral approaches, predominantly SI bone and the iFuse. This is a heavy set patient here, but these devices, lots of screws, different cannulations in the screws. These cannulations are designed to provide a fusion mechanism. But you have to traverse through all of this tissue to get to the crest to deliver the screw across the joint. But how are you addressing any fusion here? You're just putting a screw and hoping that some kind of bone grows in this hole. And these are all pre-1976 predicates of, trauma systems. So it's an easy regulatory, there's not really a barrier there, but also SI Bone has done a great job of really creating that, the relationships with payers, et cetera, that do pay a substantial price for this.
There's no question, we do have to give credit. SI Bone has created this market, and they need, they come under some sharp criticism from different sources, but there's no getting away from the fact that they deserve credit for having created this market, or at least brought to the world's cognizance that this entity is real.
Absolutely. But most of these laterals do require 3 devices going across the joint, and again, more just stabilization. And too long of a device here, you're in the bowel. There are other sacral nerves and a gluteal artery that if that is hit, it can be life-threatening. So it requires a lot of precision, but a lot of traversing through tissues to get these devices in. Now, looking at another approach that's out there with the posterior lateral transiliac is basically the same concept, but more pivoting more to the posterior, where you're not dealing with as much tissue, but you're still putting a stabilization device across the joint to hold it together, but not necessarily fuse. So this is where we're focusing on the posterior intra-articular approach. Again, remembering mind the gap, we're kind of filling the gap because there's a corridor of putting a device in, targeting with a K-wire, using minimally invasive concepts with dilation and working through a window with the aperture of the final cage, using bone prep instruments to prepare the bone around the joint and getting rid of the cartilage, et cetera, to help promote the fusion, and then inserting this rectangular cage and then deploying the wings, which will carve out or hog out bone in the ilium and the sacrum, allowing stabilization, but also, allowing for the fusion concept to occur with the pre-filled cage with the patient's own bone or other bone void filler. This is well patented. Frank and Dr. Shankman got this patented back in April officially here in the US. There are some other entities outside the US that are also covered. So it does have the IP, and we have a continuation in part as well that tagged along with that to include other concepts. But we do have prototypes here to kind of show the mechanism. To kind of show how the device would kind of look and deploy, positive clicks, et cetera, and then placed into a sawbone. And that's kind of the gist of the presentation. As I said, we're really at a pre-revenue early stage. The key here is to raise $500,000 to complete the development, get through the testing, and then submit to the FDA and do other things to get the company with quality management systems in place, looking at breakthrough device designation pathways, reimbursement landscaping, et cetera. So looking for that funding to finish all those things, to then get through the FDA, to then address a market launch potentially late next year, but most likely 2026, where further funding would come along to get ready for a market launch to get this out there. All right.
Thanks. Got 2 questions already from Asher and Elizabeth. Go ahead, Asher.
I had a couple quick questions. Can you explain how this system is different to the bow tie system from Cell Fusion that just launched like a week ago, or the SIDSys system that Dr. Donner has been working on? Just out of curiosity.
Yeah, the bow tie is more of a inferior approach to the SI joint, and you're putting more of a kind of a beam through the joint. But you do have lateral transfixing screws, a screw that goes across. But again, you're just putting something in, and bone is adhering to the device. Is it actually fusing? And
That help?
does
That
that help?
help, Asher?
So
Sorry, I
we're
forgot I was muted.
actually,
Yep.
yeah.
And
So
then
we're
how would this differ from SIDSIS then?
the SI. I'm not familiar with the SIDSIS. I'm familiar with Jeff Donner's patents and work
Yeah.
with.
Dr. Donner's patents I'm very familiar with his work, and actually, uh, in a way, I think we've mirrored each other because I applied for this a long time ago, but I think it's a little different than Dr. Donner's work, the SIDSIS, because the way our wings deploy when they rotate, they're lucky. I know he's got a similar cruciate design, but as far as I know, it's not rotating and first of all gathering some of the patient's own bone to help contribute to the fusion mass. And secondly, it goes in as a cruciate design. And I know he's got a lot of different designs. The one I believe is going in as a cruciate device, and the whole device is kind of rotated a little bit. So there is some similarity, no question. But I think the bone windows that we have in this device to create a large area for fusion mass to grow through is a very differentiating feature from what he's got.
And the transfixing aspect is within the cage versus a external screw or lateral screw that stabilizes to hold any intra-articular device in.
Got it. I appreciate that. Thanks. Yeah, this is a
Thank
huge.
you. Thanks for the
huge-
question.
Yeah, this is a
Good
huge,
question.
fast-growing space. I've got a little bit of experience selling the lateral, SI screws. So I wish you guys the best of luck because this is an exploding market.
Thank you, Asher.
Elizabeth.
Hi, so I've read that a couple of things here, and this is probably way ahead since you're in the fundraising stage, ahead of the curve in a way. This SI pain is more common among women, correct?
Yes, that's correct.
And I don't know if this transfers, but low back pain, you find the risk factors are smoking and obesity and sitting too much all day or not moving. Does that transfer into the 25% that are the SI folks too? Is the same kind of thing?
That's a really good question. That's a great question. And, we identified some of these as responsible for low back pain, not necessarily all of them. And of course, I didn't learn all that much in medical school, but one thing I did learn is that you can exercise, you can eat the right diet, you can not smoke. The most important thing for all health is to pick the right parents. Because if you pick the right parents, you've got 60% of the game already. So there is a genetic component to everything, and including low back, and we can't get away from that. I think there is some differences, though. Coming back to your point specifically, I think there is some differentiating factors. As you say, SI is more common in women, and one reason is particularly postpartum women, because we know that hormones such as oxytocin, which is released, just prior to birth, and probably some of the others, maybe even estrogen itself, serves to relax the muscles and the tendons and ligaments, particularly the very strong posterior interosseous ligament, which fills the gap that Anthony's reminding us to mind. Those ligaments all get relaxed. And remember, I mentioned during the presentation that I think we're going to eventually find that movement is not as important as the way forces are being managed by the joint. And so if in a woman once those ligaments have been relaxed, there's pretty good evidence to suggest they probably don't come back to their original composition. So I think that's a preceding factor to why women get this more than men. Also, the shape of their pelvis is inherently designed to propagate the species and therefore carry a baby. The way the symphysis pubis is designed is different in a man, and all these things may come into effect. One thing that's interesting is there have been almost no studies at looking at the symphysis pubis once you fuse the SI joint. There was just a German study from a number of years ago that did show that starts to wear down, because after all, it's a continuous ring. So what you do to one part of the ring is going to have an effect somewhere else in the ring. On the other hand, there also is evidence to suggest that smoking affects every joint, right? I mean, smokers have a higher problem with hips, knees, ankles, you name it. And obesity is going to have a contributing factor in the setting of SI problems, because it's a very heavily loaded joint. And all of the weight of the torso is meeting the forces coming up, being transmitted up from the floor through the lower extremity. So an obese person is going to also be more inclined to have SI. I saw a lot of people where I live in central New York, Utica, New York. We used to joke around, and again, Tiger said this is not going to be going around the world, so I don't have to have anybody coming back at me from Utica, but we used to measure patients in terms of Utica units, which is 2.5 times the size of a normal person, because you have a lot, you have a lot of obesity, unfortunately, in this area.
I think you might have said
And
that from Louisiana. We were just ranked number 1, I believe.
well, if you selected small spots around the world, Utica would be right up there, trust me. It's so you have all of those factors. So I do think that there is some crossover, but I don't know that we've defined it that well yet. Great question. Great question.
Thank you. It'll be really interesting to show going forward if there's a limit, BMI limit. Pardon me. I think you get the point. Thank you.
Yeah, no, absolutely.
Great.
Absolutely.
Great.
And some of the things we hope to do as our pipeline starts to move out may look at questions like that, because we want to start looking more at the diagnosis rather than just the fusion. I personally think that's a very critical part of the whole subject of the SI joint. I have to say, I was at a meeting a couple years ago, and one of the Park City meeting, and one of the sessions was SI pain and what do you do with it? Half of the room was surgeons and the other half were pain management people. And at the end, the moderator asked, okay, here's the big question. Are we doing enough SI fusions? And this was like the halls of Congress, the surgeons on one side of the aisle and the pain guys on the other. Are we doing enough SI fusions? All the surgeons raised their hand. To the last surgeon, every last one of them, every man and woman raised their hand. Are we doing too many SI fusions? The other side of the room, the pain management people, all of them raised their hand, every last one of them, and said, yeah, we're definitely doing too many SI fusions. So I think it is incumbent upon us to take care of patients, to also start to look at, who really should get a fusion and who. Because I think it's a complicated situation. I think there are people that have a flare-up that may go away, and you fuse them. Now you've started to affect things upstream and downstream. There's no way. Everybody on this call would agree with one thing, and that is you can't fuse one part of the musculoskeletal system and not expect upstream and downstream effects from that fusion.
Yeah, well documented. Good question, Elizabeth. So Dennis is up, and then Andrea.
So first of all, thank you both for a great presentation. I spent a lot of time in the SI pain market. What's your go-to-market strategy, and what type of investment are you looking for?
Yeah, no, great question. So we're looking for $500,000 to kind of finish up the development and get through FDA, but about, another 3 million to get into a softer kind of launch to 10, 20 centers across the US, with that. Targeted centers that, obviously surgeons that do SI joint procedures, take it up. And then from
Now,
there,
will that,
using
I'm sorry.
using, to start a traditional 1099 sales distribution model.
And will those 10, 20 centers that you're going to go to, will they all be spine surgeons? Are you going to mix them with interventional?
Yeah, if that does come up, that's something we want to look at, because there are interventional pain guys that do address this very well and not just release it into the hands of, any pain doctor, so to speak, as you've seen in these interspinous devices. It's, very intricate and unique anatomy as it is already, but definitely someone that's very familiar, predominantly spine physicians.
Okay. Thank you. It's just the cat's out of the bag on this. Even in the last spine meeting, I had a focus group like 2 weeks ago, and they're already admitting that this is something that is out. There's no reel on this one back in.
No, you can't put this genie back in the bottle.
There's not going back in the bottle.
Tiger, may I just go back to Asher's question and tell him, just give you an update. On my other computer, I just pulled up SIDesis. I didn't want to say this until I was 100% sure, but SIDesis also uses a screw that comes through the ilium. And part of what we're trying to do is to avoid any screws going through the ilium, because even though they're not that big, that's still, weakening a bone that we feel doesn't need to be weakened. So that's a very critical discriminator between our technology and SIDesis.
Thanks. Yeah. Thanks for clarifying. So Andrea's up, our patent expert.
Yeah, so it's really interesting. I did a project not too long ago, kind of sort of related. And so, yeah, in addition to Dr. Donner that Asher mentioned, Orthocision also has a good patent portfolio, kind of protecting posterior SI joint fusion. So it's worth looking at their stuff as well.
I have, but thank you very much for bringing that to our attention. That is, you're right. They do have very good stuff. There is a lot of good stuff out there.
And it's like you said, this has been around for a long time, but there has been patent litigation. So it is, I think, and especially as it's becoming, like I said, more and more of a hot topic. It's worth protecting it, but also keeping an eye on what other people have. It looks like they're patenting instruments and methods of doing surgery and systems. So like the whole shebang, which is a sign that it's a thriving sort of landscape.
Absolutely.
No, thanks, Andrea.
Sure.
Thanks, Andrea. Alyssa's up.
Hello. On that note, actually, I looked in the MOD reports and it said 97.5% of the MOD complaints were due to improper positioning of the implant and user error. So I think it's really valid that they're putting patents along their instrumentation doing to prevent that issue.
So it could be not device related, but method related, surgical procedure related.
Or training related as well.
Yeah, there's I think it was almost 1,200 reports. So,
yeah.
And a lot of those, as you know, don't even get it reported. So
that's right. That's
Alyssa, thank you first of all, it's nice to meet you, Alyssa. We've chatted on LinkedIn, but it's nice to meet you. Secondly, thanks for bringing that up, because I do think that almost all of them, I'm going out on a limb, but I think almost all of the MOD reports are for for lateral rather than posterior issues, because that is the issue where you can wind up just tiny bit of little being off your trajectory a little bit, especially in a larger person where there's a larger traverse to get to that little window of bone that you have to go through to get a lateral fusion in place. The posterior is a little bit more intuitive. Some of you are probably too young to know who Willie Sutton was, but the Willie Sutton rule of going where the money's at. You posteriorly, there's very little that you have to actually get to. And I was mentioning to Anthony, we were talking the other day, and I was mentioning that I had always noticed that even if you had somebody that was a larger person, a larger individual, for some reason, that doesn't translate to the little area, the small of their back. No matter how big they were, you might have a struggle getting to their neck, but get to the SI, to get to the SI and to get to the L5S1, the lumbosacral junction, there just never seems to be one area where the subcutaneous tissue doesn't deposit as exuberantly as it might elsewhere. And so just my observation. If there's any other surgeons here, please speak up. But that has been my observation. Even in cadaver studies, you'll see it.
Yeah.
It's kind of an
Well, if you
interesting
ever
thing.
need to work around some patents, you can license our ability to deliver therapeutics through the devices.
Yeah, there you go.
Thank you. That sounds great.
Got a licensing deal brewing. That's incredible.
Well, she's got some interesting delivery systems.
Yes.
It might be something that we could actually combine your delivery systems with going into the SI joint and delivering bone graft to it, to our cage.
Well, actually, where we're having a lot of response is from an oncology standpoint, because prostate cancer, lymphomas, they go into the spine, and you don't take away all of that bone. You don't resect it all. So it would be nice if there's a T cell activator that can spot target the lesion, and so you don't have to. You can minimize the all over body chemotherapy. So that's another one, as well
Very
as from an
interesting.
antibiotic placement.
Very interesting stuff. Very, very interesting stuff. Reminds me of doing lac cell surgery in the brain many years ago to try to target the tumors in the brain, lymphocyte activated killer cells, lac cells. We were lacking data to make it very attractive, but it was an interesting approach.
Yeah, we don't want to do the research on it. It's too expensive. But if we find a drug delivery like Pfizer or an oncology partner that we just literally hand the screws to, and it could be a nice pairing.
That would be great.
Oh, no, nobody's hands raised. I actually have two questions for Anthony and Frank. So I've seen a lot of startups at this phase, and you patents and you're generating money and going down the regulatory path. And the question is always, how do you test the idea as early as possible? So how do you test the device? It's rare to have the first design be the best design. It's usually design 3 or 7 or 15 that ends up being the home run. So how do you test the device? And the second question is, how do you really test the regulatory pathway?
Yeah, no, great question, Tiger. I mean, obviously biomechanical testing is critical for where we fall into the with a FISA 510K clearance. But yeah, it's very specific, and who we're working with, knows the model on how to test it specifically to satisfy those requirements. But it's really more, don't get too entrenched on, adding bells and whistles to it to, the competition's doing this or that. Go in and get your generation 1 out there, get some market acceleration with that, get feedback, and then channel that feedback into what could be a Gen 2 and moving onward to make it better. But yeah, it's purely the biomechanical testing, and then we'll work with actual spine surgeons on the development of the procedure and the instruments. We want to keep it very streamlined, minimal instrumentation to start. so that it simplifies everything.
Yeah, so I mean, I've blown this horn before, but I'll blow it again. I really think you need clinical feedback as early as possible before you even have a 510K. So, I mean, I would definitely look at doing a few surgeries overseas somewhere.
That,
And you,
um,
yeah,
that is- yeah, that's on the radar and in discussions.
good, good. And then how do you test the regulatory pathway? Um, so it's not a straight up 510K, it's a breakthrough, is that right?
No, the breakthrough is a pre kind of regulatory process, and it's really geared toward, looking at, it's a 60-day window where they review it, and you kind of know what that 60 days, but there's advantages from what Frank and I have seen with past projects. Even if you don't get it, at least it's been reviewed probably by that same reviewer that will look at the 510K application. But should you receive it, and they are decreasing spinal implants in particular with the breakthrough, but there are add-on payments, et cetera, if it is successful, and of course the marketing that can come along with it. But then with that, that's just one little caveat, which could speed up the 510K as it's already been reviewed with the breakthrough.
So you think you're going to get a traditional 510K?
Yes.
Do you need clinicals? Okay, that's excellent. Because it is a new device. It's kind of a new device in a new space.
It's a new strategy,
Yeah.
device strategy. And we've actually, just to expand the answer to your question a little bit, we have talked to Emergo about this a number of times, and actually also to MICRA, the guys over at MICRA. And I mean, I think they give you pretty solid advice, and both of them felt that this was going to be a 510K. Probably using two predicates, not one, using a posterior system as one predicate, and then tagging on a lateral system, because actually we see one of the advantages to our system is that it combines the better points of both systems. It combines the ease of approach and the safety of the posterior approach. But those who are champions for the lateral approach feel that one of the big things you get with the lateral approach is you cross the joint.
Perpendicular.
You bridge the joint with the, well, that's what our wings do. When our wings deploy, they're actually bridging the joint. So it was actually suggested that we'll use a primary and secondary predicate device as a regulatory strategy.
That's really interesting. So you have the safety of just going up posteriorly, but then you have the fixation advantage of being perpendicular.
And the largest window, if you actually look at our windows, the largest window for bone graft to grow there through.
Right, makes sense.
Plus, we're also following AO principles in as much that we prep the joint, we remove at least some of the cartilage and some of the cortical bone. So you actually have bleeding bone confronting bleeding bone through our window. And, even the bow tie doesn't do that, nor does, Donner does to a degree. He wants to get the joint cleaned out. So he's following AO principles, but the vast majority, none of the lateral groups, with the exception of SI Imetry, they actually had a little device that came out, did a 90-degree turn, and they could scrape off at least the cartilage. They weren't doing anything about the cortical bone, but at least they were they were scrubbing the cartilage off, which is step one.
Yeah. So Asher's got a follow-up.
Yeah, actually, I had a few questions, but you guys kind of had already hit a lot of them in terms of, working with Empirical or somebody else to do a breakthrough device designation. And then MICRA, again, was super valuable for us, helping us define an existing CPT code pathway. And for you, it may make even sense to look into like a novel ICD-10 code or a NTAP code just for, higher reimbursement. The only last point I had was, I know this is a huge area where people are looking at single-use instrument, pre-sterilized instrument packs where you can, just open it up and you bundle that cost in with the implant. So, definitely something to look into if you're that early
Well,
stage to pull it off.
That's definitely on our plan.
Yeah,
Yeah.
get some market validation on what we have, and then look to streamline it through that disposable option.
Yep.
How many sizes do you think you'll go out initially with soft launch?
Probably 3.
Okay.
Yeah, or what we might do alternatively, rather than have sizes, is go with the recommendation of using 2. If it's a larger patient, just using 2 rather than creating a large size, because there's a limit to how big you can make this before it becomes realistically difficult to get into the joint without doing, converting it from an MIS to just an open procedure. So there's a limit to how big the implant can be, but there's no limit to how many implants you can put in. So if you have somebody that's larger, or if the surgeon, for one reason or another, feels that it's going to make more sense, he can use 2.
Interesting. I remember when the BAK cage came out in the 90s, it only came in 2 or 3 sizes, I think. And
Yeah, it was the large and the small, and then they came up with that one that has the one that had a reduced lateral
taper
side to it.
Yeah.
And funny you say that, Tiger, because the engineering side who we're going to work with had some experience in the early, late 90s and early 2000s with a surgeon up in Michigan, I believe, that used an interfix like device in the SI joint, and that what they saw early on was, the slight distraction, allowing the tension of the posterior ligaments allowed a lot more compression, and these patients did really extremely well. But as you know, Medtronic didn't jump on that because SI.
Interesting. What other questions?
Usually Mark's always participating. I hadn't heard him yet.
Yeah, well, I don't have a huge amount of spine background, but I had a couple of observations. One, it's good to see that Frank has proven once again that the funniest surgeons in the operating room are always the neurosurgeons. They have the best senses of humor, I swear. And another thing too, when I first tuned in, I was really excited because I thought I was going to meet the son of the author of The Wizard of Oz.
Oh, spelled differently, but interesting that you mention it, because Canastota, which is where he lived for a fair amount of time, is about 25 miles from where I live right now, where I am. Yeah, there you go.
See, there you go. Yeah, there's a tornado in your future. Have you considered custom implants? Is there anything, is that a good business plan for a new entry?
You mean 3D printed? You mean 3D printed to the patient?
The actual implant itself, like
yeah, 3D.
People are doing for total knees and everything. Is there any economic reason for that, or is it strictly just not a good idea?
I think in some spaces, like the spine, it may make some sense, but in the SI joint, what we find is it doesn't vary that much from patient to patient. You have a larger person, of course, the joint is larger, but the individual variations of the anatomy are not that striking. Now, there was just a paper published not too long ago that did look and say that this could be an explanation for failed SI fusion, which, is also a separate topic. SI fusion is having a failure rate of about 20 to 25% if you go out more than 2 years. So, and that's the basis for some of our other products that we've got in the pipeline. But your question's a good one, a really good one. Is this actually just a gimmick, this 3D printed thing, or is there an economic upside to it? And I think the answer is that we have no answer yet. I think that I don't think there's enough experience with it to know whether there's actually, and certainly anybody that knows something about that can please step in and help me out here. But I think at this point, it's one of those things that intuitively seems okay, but at the end of the road, maybe just a gimmick. I just think we have to know more about it.
Yeah,
Great.
I think 3D printing makes sense for severe bone loss, oncology, weird anatomy, but it's
Mhm.
not for just not your everyday surgery.
I
Yeah.
don't know. I think now granted, obviously I have a different perspective, but there was, if you need to achieve certain architecture to increase structural stability, or there's a reason why we've been able to meet ASTM 1717 for the smaller size of screws, and nobody else has been able to. And we have tested many designs, and the one that keeps passing would never have been able to be achieved with traditional subtractive manufacturing.
That's a great point. You can do things with design with 3D printing you could never do with milling and lathe work.
Yeah,
And
no,
so I
think
do agree on the 3D. I do agree that it can be a little bit of a fad, but though at the same
I think
point.
we're going to define the subpopulation where it's really appropriate. But I think it may not make economic sense. I mean, Mark's question was a really good one. Does it make economic sense? It makes theoretic sense. Theoretic sense, you 3D print every implant to specifically fit the patient. But then you get in there and you wind up doing a little more bone work than you expected to, or you alter the anatomy surgically that you didn't expect that to happen when you 3D printed the thing. And, I don't know if people are running into problems. I've heard a couple of stories where people are running
Oh
into
yeah.
problems with that aspect of it.
With custom
So-
guides, if you lose the architecture, you lose all of your alignment.
Exactly.
And so the only way, I'm not a big fan of computer navigation, but because I've seen catastrophic issues
So have I.
occur with computer navigation.
Yeah.
That would never have happened before because you don't have a mineral density registration. However, if you can pair AI for spine in particular, because spine is very complex with all the angulations that are required. If you can combine AI with bone mineral density mapping and really understand what you're working with prior to insertion, and the machine guides the prosthesis placement, I think there might be a really nice opportunity there for custom, but I think we're a long way from custom application for that.
Yeah, I think bone density is a big thing, and that's where 3D printing can be very helpful. But I also think we're really early on in the medical 3D printing has been around for a very long time, right? Many decades, but medical 3D printing not that long. And I think it still needs to get to the hospital. So once 3D printing can happen in hospital, maybe once the patient is open and like you said, Dr. Boehm, where everything has been done and the debridement, everything, and then you do your imaging and then you create the implant to specification, but the technology is not there yet and the infrastructure and everything. So
unfortunately, Mark actually asked the critical question, and that is the economics of it,
right,
because that's going to drive everything.
Yeah.
And, if it, no matter how wonderful all of this sounds, if it's not going to make economic sense to the decision makers at the insurance companies, it ain't going to happen. And that's really the bottom line, no matter how theoretically wonderful we want it all to sound.
Well, and also people make it seem like you put in a file and the 3D printer just does everything and it's going to be perfect. And I could tell you that we would not exist without pushing the machines to the limit, the most expensive dual laser machines to the limit, and customizing parts on the actual machine itself. So to think that, I mean, if companies like DePuy and Johnson & Johnson can't even figure out the machines and they have full-time people running them, there's no way that a hospital is going to be able to. They don't understand the machine learning capacity is so vast, and there's very few people that really understand the machines and the design capabilities and how to design, because our failure last year revolved around a 30-year veteran engineer who had 7 3D printers at his house, and the design failed at 5% in testing.
Yeah, there's more art than science. Yep. Kyle's
so is surgery, by the way.
Exactly. Kyle's got a comment or question.
Yeah, so admittedly, I am very naive when it comes to the spine space, but Alyssa mentioned something I think is really interesting, especially if you guys are not at the point of finalized development of your implant, and I would assume that means you're still working through your instrumentation. She mentioned that there's a large number of mod reports and that a high percentage of them have commentary around user error, or that the implant wasn't placed right, or the instruments were used wrong. Now, that could mean a couple of things. Could mean that there's innovation opportunity with the instrumentation. That's fine. It could mean that there's educational demands on a surgery that is difficult to do. It also could mean that you've got a bad implant design, because if an implant can only go in when everything is perfect and every instrument is aligned the right way and all exposures exactly the same, and your anatomy is just right, if that's the only circumstance in which implant works, then you have a bad implant, because the likelihood of all of those stars aligning perfectly is low. So I would encourage you guys to actually make use of those mod reports as a tool to see how much you can flesh out what some of those pain points are. That, what is the user error that is being defined? Is it that a reamer is unwinding? Is it that a wire is bending? Is it that something is breaking off? And use that to feed into the functionality of not just your instruments, but your implants as well.
That's a very, very, very good point. And again, I think a very large number of those mod reports are associated with lateral approaches. And the lateral approach, one nice thing about the posterior approach, Kyle, is it's significantly less demanding in terms of the precision of the placement of the implant and the precision of the use of the instrumentation. It's significantly less demanding than the lateral approach. The lateral approach is all the things you just talked about, but you're right. And that's a very good point. I think we will make sure to do that, to look at those and make sure that there's nothing that rings a bell in those mod reports in terms of our instrumentation. So thank you. That's great.
Are you guys thinking about having a flexible reamer to sort of go through the crevice, the joint space, or straight reamers?
Flexible as bending mid shaft, or
like a flexible reamer in trauma, or like what CurvaFix has. So it follows the path of least resistance.
Yeah,
over a guide wire.
That's definitely a good point and something to consider. Again, it's really just, as we get to that step of development, we're going to look at that, but definitely that's some good feedback to look at. Because again, just different, the uniqueness of the approach being direct posterior, like all things, it should be relatively straightforward, but you gotta have flexibility for ease of use.
Yeah, if you get a guide wire into that joint, then the reamer, it can't go off track. So
we start with Anthony sort of quickly moved through the procedure the actual surgical procedure for our device. But that's right, Tiger. We do start with the guide wire. Make sure the guide wire is in. And actually, we're going to recommend a guide wire that has a channel through it, so the surgeon can do an arthrogram. And we do an arthrogram, and you actually prove you're in the joint. Then it's sort of it's you're on the fly from there. You're pretty much gonna the
You
dominoes should
should,
fall.
yeah, you should talk to Spine Guard because they have a sensing device that tells you if you're in blood, cartilage, bone. That may be an interesting. You'd have to modify the device, but
Yeah.
interesting. Well, we've gone over time, so if Mark doesn't have any more great questions, it's a wrap. This has been fascinating. Good luck to you guys, and BoneChat's here for you, so feel free to come back and give us an update.
Thank you very much. Thank everybody. I want to thank everybody for your input. They're really great
Thanks,
questions and
Boehm.
great
Thanks,
points.
Anthony.
Thanks.
Yeah, no worries. Y'all take care.
Good
Thank
luck.
you.